One of the difficulties in finding a gaming device like Anbernic and Paucity is knowing which model to buy and how to decide whether it's the right time to replace your current one or buy a new one. So I thought I'd create this video to give you some background on how to go about it. So, it's necessary to have a little explanation about computer architecture and some components, such as SoC, CPU, and GPU, and other things. I hope it's useful, so let's go. The Central Processing Unit, or CPU, is the brain of the computer. It is the primary component that performs most of the processing. For the computer, it is where all the thinking happens. The CPU is often referred to as the processor. It is a chip located on the motherboard. It consists of an arithmetic and logic unit, or ALU, a control unit, cache memory, and various registers. The CPU job is to process instructions and operations of a computer system. The basic working mechanism of a CPU, often known as the fetch-decode-execute cycle, or as the instruction cycle. The first step is where the CPU fetches, the instruction from the main memory. The second step, decode. This part is to determine what the instruction means and what actions must be taken to execute it. The third part is the execute, where the CPU carries out the actions required by the instruction. Modern CPUs can go through billions of these cycles in a single second. Multiple instruction cycles can overlap using pipelining. This allows CPUs to fetch the next instruction before the current one has been completely executed. A CPU is usually a small square or a rectangular chip, and it fits into a dedicated socket on the computer's motherboard. The two main manufacturers for CPUs are Intel and AMD. Intel processors examples include Intel Core i3, i5, i7, and i9 series. In general, the higher the number, the more powerful the CPU is and includes more CPU cores. Sometimes, you will see a sticker on the computer telling you what type of CPU it has. The other company is AMD. One of their common types is the Ryzen series, Ryzen 3, 5, 7, and 9. For Mac computers from Apple, they use Apple Silicon called M1 and M2 that has a CPU built into that chip. And for retro gaming devices, the Cortex-A family, in general. Obviously, considering the vast majority of retro gaming devices such as Anbernic and Paucity, the motherboard is not used for reasons of size, but rather an SoC, system on a chip, which is a chip that integrates multiple types of processors within the same integrated circuit, which we'll talk about shortly. And to finish off this section, processors have a related architecture, which is a set of instructions that decode and execute arithmetic and logical operations. Although we only come into contact with x86, there are a variety of architectures such as CISC, RISC, EPIC, and ZISC, and in the world of retro gaming devices, the ARM architecture, which is a family of RISC-type processor architectures, i.e. based on a simplified set of instructions that define how the processor works. Remember that the CPU plays a crucial role in the performance of a game, especially when considering a system-on-chip, SoC, used in devices like the Anbernic and Paucity handheld gaming consoles. A better performing CPU can significantly enhance the gaming experience by reducing latency, processing information faster, and allowing the device to run sophisticated applications, including complex games. However, an SoC integrates not only the CPU but also other components such as the graphics processing unit, GPU, and sometimes even neural processing units, NPUs, for AI tasks. In gaming, both the CPU and GPU are critical, with the GPU handling the rendering of graphics and the CPU taking care of the game's logic and physics, and that's what we're going to talk about now, so let's get to it. Graphics Processing Unit, or GPU, is a hardware component that turns data, ones and zeros, into visuals. It is responsible for computing visuals, images, graphics, animations, and videos, and display them to your computer monitor. If the CPU is the brain, then the GPU is like the artist of the computer. CPUs are responsible for interpreting most of the computer's command, while GPUs focus on graphics. Here's an overview of how GPU works. The Graphics Processing Unit, or GPU, takes data related to graphics from the CPU. This information is then used to compute the appearance, color, texture, and shape of every pixel that you see on the screen. GPU allows the CPU to do other tasks by handling the graphical computation. The GPUs perform these computations quickly using hundreds or even thousands of cores. So GPUs are perfectly suited for rendering complex images or videos in real time, like in video games and design software. Also, GPUs with their multiple cores are designed for parallel processing, where multiple cores handle separate parts of the same task. So calculations are performed simultaneously, and this is helpful in machine learning. Training a machine learning model involves performing numerous small calculations at the same time, which is something GPUs are exceptionally good at due to their architecture. For that, GPUs are used in applications related to artificial intelligence, deep learning, scientific computing, data analysis, image recognition, and audio processing, to name a few. GPUs also have their own dedicated memory called the video RAM, or VRAM. VRAM is faster than regular RAM because the data is stored directly on the graphics card, so data can be processed and displayed quickly. The more VRAM a GPU has, the more data it can store for quick access. A more powerful GPU can significantly improve the gaming experience, allowing games to display more detail and graphic effects, as well as achieving higher frame rates. In SOCs, the GPU works together with the CPU to provide a balance between performance and energy efficiency. Devices such as the Anbernic RG505 and Paucity X28 use SOCs with GPUs such as the ARM Mali G52EE, which offer graphics performance suitable for retro games and emulation. You'll notice that the vast majority of these devices will use the Mali GPU. Mali is a series of graphics processing units produced by ARM Holdings. The GPUs are mainly used in mobile devices, which include retro gaming devices. However, the amount of RAM and thermal efficiency are also important factors that can affect the overall performance of the game, and let's talk about RAM now. There are two main types of RAM: dynamic RAM, or DRAM, and static RAM, or SRAM. Dynamic RAM is based on one transistor, one capacitor cell structure. The capacitor is to store data, a bit, 0 or 1. The transistor acts as a switch for reading and changing the capacitor state. Drum capacitors have a tendency to leak electrons and lose their charge, so they must be refreshed periodically to return their data, hence the name, dynamic. In static RAM, the data is stored using the state of a 6-transistor memory cell, 4 to store the bit and 2 to control access to the cell. In this type of RAM, there is no need to periodically refresh it, making it static. SRAMs are more expensive and faster than DRAMs because they don't need to be refreshed periodically. However, they don't store as much data as DRAMs. SRAM often used for cache memory in CPUs because of its speed, as it allows for quicker data access. Dynamic RAM comes in different types, like synchronous dynamic RAM, or SDRAM, and double data rate, or DDR. SDRAM was developed first, and then DDR came afterward. Synchronous DRAM is used to sync the CPU clock speed with the memory speed. DDR transferred data twice per clock speed, hence the name double data rate. There are several generations of DDR, including DDR2, 3, 4, and 5. Each generation offers significant improvement in speed, power efficiency, and overall performance. For example, for each generation, different capacities, typically ranging from 2 GB to 128 GB per module. In the vast majority of retro gaming devices, you'll see the term LPDDR, LPDDR4, for example. LPDDR, which stands for low-powered double data rate, is designed for mobile devices and offers reduced power consumption at the cost of bandwidth. RAM plays a crucial role in gaming, as it stores data that the CPU needs to access quickly, including game assets, textures, and level information. In the case of Anbernic and Paucity devices, the amount of RAM, such as 4 GB LPDDR4X RAM, can directly impact the device's ability to run games smoothly and handle multitasking efficiently. That said, a question may arise. How is all this integrated? Well, the answer is System on a Chip, or SoC. An SoC serves to integrate different types of processors, such as CPU, GPU, NPU, and ISP, on a single silicon chip. The integration of processors within the same chip makes it possible to optimize the system's performance and energy efficiency, which is important for devices that use batteries. In addition, an SoC tends to be more compact than separate processors, which improves portability. In other words, when we research the SoC of a retro gaming device, we will automatically know its CPU and GPU, as well as other things, such as the NPU, which is a neural processor whose function is to accelerate machine learning and artificial intelligence tasks, the controllers, such as USB and HDMI connections, the modems and radios, such as internet access via 5G and Wi-Fi, Bluetooth and NFC connections, and the DSP, which performs digital signal calculations to process audio and video. Tasks. The vast majority of retro gaming devices use the Rockchip SoC, such as the RK3566, as well as the Unisoc, such as the Tiger T618, and finally the MediaTek SoC, such as the Ionio device, the Pocket Air, which uses the MediaTek Dimensity 1200. Well, that's the end of that. This video serves as a basis for knowing where to start looking in technical terms for the retro gaming device you're interested in and what its impact is on emulation performance. I hope you find it useful. Another question is how this results in the emulation capacity and performance of the devices, and I'll talk about that in another video. But I can give you a simple hint and what the results mean. The Geekbench website measures your device's CPU and GPU compute performance and usually shows this through scores, which are the CPU score, such as the single-core score and multi-core score, and the GPU score, Vulkan score. A higher Vulkan score indicates better graphical processing capabilities, which is important for rendering the visuals of a game smoothly. A higher single-core score suggests that the SoC can handle these types of tasks more efficiently, which is crucial for emulating older consoles that rely on strong single-core CPU performance. A higher multi-core score indicates that the SoC is better at handling tasks that can be parallelized across multiple cores, which can be beneficial for emulating more recent consoles that were designed with multi-core processors in mind. Sounds easy, doesn't it? And it is. Well, I'm finishing up here. Thank you for watching, and if you like this type of video, consider subscribing, comment anything, leave a like, and see you next time.